Yeah, first I would like to thank Jerry. I think this is one of the nicest collaborations of software collaborations I've ever had in my life. So very glad that he joined this team. I very often tied to projects which are very boring in that sense and not really rewarding, but yeah, it's always nice to find other people who are obsessed with benchmarking and doing the dirty stuff in the in the background. Yeah, so KM3io.jl, I thought I would like to show you a small project which uses UnROOT to make things a little bit easier for the end users. And I was asked very often how to make UnROOT work for their own systems or for their own structures. So this will be some kind of a reference talk, I guess. I will show a lot of nasty code, and it will be also quite short, but I think it will scratch the surface good enough to open up better, more questions or ideas how to make things nicer. So yeah, this will make UnROOT.jl comfortable for at least KM3NeT. We use root in KM3NeT very often. It's one of our main data formats. So this package is meant to read all these KM3NeT root file formats. And as you already know, it uses UnROOT to access all the root data behind the scenes. And this package provides convenient wrapper functions to iterate through events and other types of structures. So data are read lazily, as Jerry already showed. And so this means that they are only loaded into memory when directly accessed. And this package also contains many commonly used utility functions. So a little bit of history. Our root files are coming from a C++ based framework, which is very tightly coupled to root. And we have a lot of custom classes. So it's unfortunately not as easy as just using UnROOT and loading a file. This will not work. So this is why we don't use UnROOT.jl directly. It would require a lot of work and a lot of details to open these files. So we have a bit more complicated structures, as I already said, many custom classes, and we sometimes also have very low branch splitting, so you are not really able to access just a single branch or a single field of some classes in your root file, but like big bunches of instances. This has several reasons. We use root for our DAQ system, for our data acquisition system, and it needs to be more performant. So we had to tweak some things like also compressions and these splitting levels and even more. We even do some bit fiddling tricks to save space and use some tricks on the C++ side, and we stretch the limits of the root streamers here and there. And we have a lot of magic numbers for mask and the indices. We use some vectors which has specific places to hold some specific information. And this we want to hide from the user. We don't want the user to type in something like 3 or so to get index 3 to get something, to avoid downstream pollutions in the code. So we use some CSV files where we define all this stuff, and we generate header files for C++, for root, and for Python, and also for Julia. If you're interested in that, I can show that too, but this would be a little bit too long for this short talk. Okay, so let's try to read some PMT hit level data. So this is what you would be presented if you simply load UnROOT and open some file from the root repository, or from the KM3NeT test data, which is a tiny Julia repository which holds a lot of samples of different root file formats and also other file formats. So here I just tried to create a lazy branch of something which is inside this KM3NeT _ event, and then KM3NeT _ event and snapshot hits. This is something which you need to know where these things are. This is what we want to hide from the user, because if they type this and we change this in future, then this needs to be changed in other code as well. So if it's hidden in the API, it's much better. The error message is also not very good here. I'm working on this. This somehow got a bit worse in the last iterations of PRs. There is a PR on the way to make the error message more mind reading, just like Chris told us yesterday. But yeah, all you see is it doesn't work. So, but if we access the branch directly, so just using this f and then the square bracket notation with the string, we get a little bit more information. So we get this so-called branch information out of the root file. And this already tells us a little bit more. So it tells you also that there is this funny C++ inheritance thing in root, which you will see a lot. So you have something like fill color and fill style or something like snapshot hits. And even more, this is like how it works. We have the same in our C++ system because we use subclassing like extensively. And we even have a small part of a C++ framework is using very generic classes and where a lot of fields only make sense in different contexts. So you need to know if you are reading this specific branch, then you should not access these fields. And sometimes it's really awkward because if you have something like integer, you don't have the concept of none. So you need to use magic numbers like -1 for energy or whatever. So you know, okay, it's not physical because it's minus, etc. Yeah, anyways, this gives you a little bit of hint what to do. So UnROOT uses this dot concatenation as identifier. So it's kind of similar to what UpRoot does. So here we need to teach UnROOT how to read something which is KM3NeT DAQ JDAQ event dot snapshot hits. And there is, so the root files themselves are self-consistent. They can describe themselves, but it's a little bit tricky to get all this information out of the file. So I did not automate it up to this point because it would make a lot of work. So here we need to hook into. And the easiest way is to look at the C++ framework itself. And if you look at the snapshot hit, you see that these are like 3 fields which are mentioned there. So you have a char and the internet char. And so the first one is just a byte. This is the PMT channel of the FPGA. Then we have some TOT, which is the time over threshold of the signal. Sorry, this is the third one. And this is the leading edge. So this is the time of the hit, which was recorded on the PMT. Yeah, when you look at the data, you realize that there must be more. And then you realize that it inherits from another class. So another int field is injected there. Yeah, in the end, this is what you need to do first. So you define your own structure in Julia, and I code it now snapshot hits, a snapshot hit. So it has this digital optical module identifier, then the channel identifier of the PMT, the time, and the TOT for the time over threshold signal. So we have this struct. And now we have to tell UnROOT how to read a single piece of a vector of those. Yeah, so the first thing you need to implement is this read type function, which takes an IO and this type, which is a snapshot hit, and it's very straightforward. So you need to use this read type method. Root is big endian based most of the time, so we have this read type function here, which already does the correct thing, but you can do whatever you want in this function. So if you encounter so we have a lot of other stuff where you need to do little endian because yeah. So I don't want to go into too much detail here. So as you can see, I'm just reading these 4 fields. This is the DOM ID, then this is the channel ID, then the time and the TOT. But that's not the full story because if you look at the branch again, what you wanted to read, you see that this snapshot hits is really an STD vector of snapshot hits. So you need to teach UnROOT also how to use how to read this field of this DAQ event class. And this is where you need to provide this interpret data, which takes in some raw data, some offsets of the data. These are coming from the baskets. And then the type you want to define. So it's a vector of snapshot hits and the JAQ type. So yeah, this is now a little bit complicated. You know, you have to know a little bit of root, but we have some convenient functions like the split up, which is able to take the raw data and the offsets and take basically the element type you want to have, and some yeah, this skip bytes equals 10 is related to the STD vector, which has this 10 bytes header here. Okay, so we defined all this. How should we continue? Well, if you open the file, you can pass a dictionary of so-called custom structs. This is how we called it. So it's simply a dictionary which has these identifiers, which I showed to you before. So for example, this KM3NeT DAQ JDAQ event dot snapshot hit. So this is this field of this class DAQ event, which is a vector of snapshot hit. So we just pass in the correct type, which is a Julia type actually. And if you open the file, it simply works. So now we can create a lazy branch, we can do all the lazy tree stuff, etc., etc. And you can see that I can also index into it, and I get back my my own types. So this is really cool because now you can use this type also to create functions, methods, dispatch on it, and so on, and also your type hierarchy. We had a lot of different type of hits also for analyzers. Okay, but it can get much more complicated, much more complicated than this example. This is just a bit more complicated structure. Here's, for example, how the event header is structured. So here we even have to tell UnROOT what the packed size is of an event header. So this is you have to spend some time in the hex editor sometimes to find these things out. Yeah, it's always good to have access to the actual root framework to open the files to make some cross-checks. We have a lot of unit tests also in KM3io to make sure that a single data bit is read correctly. But here you can see that we need to skip some bytes which are not important, or some whatever header, etc., related to C++. Then we use this read type function to read the detector ID and trigger counter, all the stuff, and then we create it. So this is very simple because we don't need to do any fancy thing. It's just using this read type. And then the interpret data is the same thing. We don't need to skip any bytes, and we have no jaggedness here. It's really just a header. Okay, and lazy trees and branches are your friends. So this is easy to create an easy to use API with that. So you can see that there is just a very simple online tree structure, which contains our online tree events, which are recorded. And I'm simply using these lazy branches, and then you can write all kind of nice, convenient functions to allow the user to iterate through these objects, and it will work out of the box. Yeah, it can. So UnROOT provides you even more things to make these branches more accessible. For example, there is this B path here. I have not included here. There's a very long path in the root file, so it's like just like this KM3NeT event / KM3NeT event, blah blah blah. So it's quite long. And then you have something like more longer paths, like hits and hits, pause, whatever. And in UnROOT, you can use regex expressions, and you can even map them to other names. So you can basically rename branches to make them more readable or more easier to access for the users. So for example, in this case, I say that everything which is under this long B path and then hits dot ID, DOM ID, or channel ID, or TDC, or total trigger T, or whatever, should be mapped to hits underscore and then channel ID, for example. So later on, I can work with them much more easily. This is truncated. There is a lot more here. And here is how it feels like. So here I'm simply using KM3io and KM3NeT test data and loading some statistics. So if I open the file, I get this little sample file, which is the online format, 3 events, 3 summary slices, and I can simply do for event in f.offline.events, because these are now offline events. And I'm showing the length of the snapshot hits and the last snapshot hit, just to show you that it works. So you can see that it's a nice vector, and it has this correct type. And yeah, also other stuff like the summary slices, which is coming also from this online tree. Here I'm calculating just the median PMT rates of some modules. This is also truncated. Yeah, another example using Monte Carlo and reconstruction data. This I actually want to show very quickly in a live session. Doesn't take too long. Let me make it a little bit bigger. So I'm using KM3io and KM3NeT test data. I'm loading up a file, and now I can use like online, and then the first event. This is an offline. No, it's offline. Sorry, F offline. So this would be the first event, and I can use the dot notation. If I hit tab, you can see that it knows what fields are there. So if I access the Monte Carlo tracks, I get all the Monte Carlo tracks. Let's take the first one, and then, for example, the position X or so. And also, if you look at this, this is again a position type, which is part of KM3io. And this is possible because in the software, so KM3io really materializes these events into their own types. The magic behind this is I'm over writing this. I'm implementing this get index for an offline tree, which was also part of the KM3io specification for a specific index. So let me show you actually the source code, or at least the truncated source code. Here's what happens if you call this get index on this offline tree, which is this wrapper struct over this lazy tree and lazy branches and whatever containers which are there. This is the original file pointer of this underscore t is the pointer to the tree to the T tree. So I'm grabbing this event, which is now a lazy instance, so it's not loading anything. And here I am creating these. I'm pulling out some stuff. There is some legacy format support, so I'm checking if this has some properties or if some branches are present in the root file. And if yes, then I'm instantiating it. If not, then I'm taking some default values or missing or whatever. So in this particular case, I'm creating a Monte Carlo tracks vector with the proper size hint to be efficient. And I'm simply pushing each Monte Carlo track using these iterators. It looks like it's horrible from a performance, but it's extremely fast. So if I simply skim over many hundred thousands of events in a file, it only takes a few seconds if I don't touch them. If I don't touch too much data, of course, in it. If I'm loading something, then it takes as long as just as like a C++ implementation or a Python implementation. Yeah, so I guess that's it. So yeah, root is not an easy format to read, let alone write. And yeah, if you need help with root files which are inaccessible for you, just open an issue. We really try to help you. We are all busy, of course, but yeah. And if you are interested in how to wrap this stuff or how to implement this stuff, you can check out the docs in the repository. It might be an inspiration for your experiment at least. Thanks.